Shishir Khandelwal. He is a senior platform engineer at PhysicsWallah. He is going to talk about a very interesting topic, keeping cloud costs low and finance team happy.
Hi everyone, good evening. So, how I like to start any talk is with a good news and followed by a bad news, right? So, the good news is all of us in the room, us engineers, we have the most powerful tools at our disposal right now, right? So, if you are a little bit skilled on Claude, on OpenAI, and if you have done some prompt engineering work, I'm pretty sure that you can also confidently say that you can build anything, right? You can wipe code anything to a very large extent. And since you are here, so a lot of you must be from the infrastructure, DevOps, platform type of backgrounds. So that's another skill set which is very powerful because not only can you now code anything, you can also deploy anything very reliably, and you will know what to look into, what to be careful about, all those kind of things, right? So that's the good news right now. The bad news is that everything costs a lot of money on the cloud, right? So cloud is a premium product, right? Everything that you do on the cloud is going to cost you a lot, right? And if there are anyone, if you're managing a cloud infrastructure of a company, these two things are something that you would be able to relate, right? So in the cloud, the fastest thing that escalates is the bill, right? That is the thing that grows more than your funding, more than your number of active users. It's the fastest growing number. Another thing is that every resource in the cloud, right? It's like a subscription, right? If you forget to turn off a resource that you're not using, you are stuck in a subscription model of something that you don't really need, right? So these are the two problems that I want to speak on right now. These are the problems that your teams might be facing, right? And this is one problem that my my team at PhysicsWallah, like, this is not just a problem for us, this is a grave problem for us, right? So for anyone who does not know, PhysicsWallah is a edtech company, and our core mission is to provide affordable, high quality education to all of India, right? And affordability is the key word that I want to talk about here. So, in order for us to be affordable, we have to keep a control on all our major cloud centers, cost centers, right? Cloud being one of the major cost center for the company, right? So, if there's anything that is happening that we are paying for, which we can avoid, it needs to be solved like turant se bhi pehle. That is what we say in our company, right? Turant se bhi pehle, we need to solve it. So that's the problem that I want to talk about here. And what I'm going to do here is I'm going to share all the ideas that my team has been working on since few years. And I'm going to talk about how to keep cloud costs low, and of course, to keep your finance teams happy, right? So this is the workflow that we work on, that we have developed over the years by a lot of iteration, by a lot of hit and tries, by a lot of research, right? So in order for you to think about cloud costs, I would suggest this mental model, right? So keeping cloud cost low is not a single project, it's like a journey, right? You'll have to do a lot of things in order for you to gain a good amount of control on it. And you can think of it in these 5 steps, right? First step is understanding. Second is discovering. I'll talk more about all these points. I'm just summarizing it for you right now, right? Third is to optimize and then automate. And of course, LLMs, AI will come into the picture. Let's start with the first step, right? Of understanding. You will be only able to solve cost when all the data, all the cloud cost, all the numbers are very visible to you, right? And visibility is provided by the cloud, right? If you're on AWS, if you're on Azure, GCP, all of them have tools that would showcase what type of cost is coming up, right? But there are few challenges with it, right? So this is like a default cost dashboard. Now, in order for you to find out what each service is costing, you actually need to know what you're looking for, right? You need to be very specific that, okay, for October 2025, I want to see the cloud cost of Kinesis, right? So this type of dashboard is helpful when you know what you're looking for, right? But when you're trying to optimize things, you are dealing with a kind of a vague problem statement, right? You can't really know what to do. You'll have to look into the whole picture. You'll have to try out few things in order for to understand that what are the things that I can save up on, right? So this dashboard does not really help with that. What I suggest you do is you create something that works for you, right? This is what works for us. We kind of created a setup where we were storing all the cost data in our S3 buckets in our different formats, and then we made it searchable, right? And then we did analysis over that, right? uh, this is the idea that we have been working on, right? So we export all our cost data to a S3 bucket on different formats, CSV, Parquet, those type of formats, and then we create tables onto that data, and then we do Athena queries on top of that data. And Athena queries are quite powerful because we can have a whole picture of the cloud using Athena queries. I'll just show it to you. I'll just show it to you with an example. So this is one of the Athena queries that we use to deep dive into our Amazon CloudWatch costs. Right over here, you can see that I am able to query the usage. I'm able to query the cost. I'm also able to see what type of pricing unit I'm being charged. What is the resources name? What is the ARN? Everything is coming over here. This type of thing you cannot get on the normal dashboard that AWS provides, right? So this type of solution lets you discover a lot more data so that you are able to take action on it. So this is step one, where you discover the data. What happens after you have done the discovery, right? Now you can go ahead and start to look for the ways that you can optimize cost. I would suggest you start with this factor of identifying hidden waste, right? Now, the like if you're in a big company, right, there are chances that your cloud would be spread across many different accounts, right? uh, in order for you to query all the data from all the accounts, it's very difficult, right? So I suggest you take a systematic approach to this problem of finding hidden waste. I start with asking three basic questions. First is, are resources actually being used fully? There must be some resources that you are using only 10%, 15%, right? Another thing is, what is running but serving no purpose? A common example of this is some audit logs, some database backups of data which was like 6 months back, right? What There's no use of keeping a backup which is 6 months old, right? It's just stale data. And third is, what has changed recently, right? So that you can very quickly know what is changing, what is going wrong, so that you can correct it whenever as soon as you discover. So expanding on these points, few examples of things that you might find when you ask yourself the question, are resources actually being used? These are common examples such as unattached storage volumes, old snapshots. There are some load balancers which are not getting any data, but they're not getting any requests, but you still have it provisioned. Another thing can be some environments that you created for a POC, or some developers environment that you created, but it's no longer being used. It's running. It's costing you a lot. It's a example of a hidden waste. Another is excessive backup retentions. And then, of course, there are few resources which are paused, stopped, but they are still being built, right? A common example is MongoDB clusters, right? So if you pause a MongoDB cluster, they will charge you less, but they will still continue to charge you. So it's a hidden waste for your cloud bin. Examples of this question: what is running but serving no purpose? It can be a database instance running at very low CPU utilization, a temporary test cluster you might have created for a migration, but the migration is done, but the cluster is still running, right? And some logging configuration, which is increasing your storage costs dramatically. So when you start looking into it in a systematic approach, like I've been, that I mentioned over here, you will start to identify such factors. The third thing is the most important one, and this is the one where you as engineers, as platform engineers, would require a lot of time, like you'll have to put a lot of time here, right? This is about what has changed recently, right? Let's say if S3 bucket was not being served by a CDN, right? It was being served directly, someone was making direct calls to S3. So now you're paying extra for that. If you make the calls using a CDN, then you can save, right? So these are some examples where you need the platform engineering background in order for you to make a decision. So what I suggest is, and what we do in our teams is a monthly audit, right? Every month we look at the data, we see what has changed, and if it has changed dramatically, then we'll deep dive into it. Majorly what I find is misses around CDN not being configured, misses around some data being transferred using the public internet and not via some pairing, VPC pairing or NAT gateway, those kind of things, right? So you can use this type of mental model to gauge your own cloud bill. And we have been able to achieve some very good outcomes by doing this. So these are a few examples. I'll just let you read the screen, and the graph actually reflects our cost around the things that I've mentioned. So first one is around the container registries. We deleted a lot of container registries. We put up an expiry on it so that the cost came down. And then there's an API gateway setup that could be replaced. Few examples of how we were able to save on the logs, right? We disabled few logs. We configured a lower retention for a few of our logs to save costs. And these are actual things from our AWS. So now that you have understood about how to identify hidden wastes, the next thing is, after you have eliminated the waste, now you can focus on what is actually meant to be run and how we can optimize that. So we can optimize it using this model that we use, right? So you can unlock cost savings step by step by, step number one is right sizing of your workloads. Next is right timing. And of course, the next is the most important one, right price modeling. I'll explain what I mean by each of these. So right sizing, what I mean is you should look into your workloads if you have specified the correct number of CPUs and memory or not, right? If not, then you should go for a VPA or a HPA type of solution so that you can improve the memory and CPU utilization. Few tools that we use to right size our workloads is CastAI, right? I am sure you must have heard a lot about CastAI today. And CADA. CADA is an open source tool that lets you scale up and scale down your Kubernetes deployments very effectively. And it has a lot of integration, so it would be able to cater to all your requirements. Another is right sizing, right? These are the outcomes of our right sizing. So as you can see on the graphs, our CPUs, the number of CPUs that our environments are utilizing has been decreasing with time. So this is how we have been able to achieve some outcomes. Right timing is also very important. So if you, for all the times, right, your traffic will not really require so many nodes that it requires in the spiky time or in the peak times, right? So you should have some scaling down during off hours. Another thing is you can use spot instances when the load is less, right? for example, at night times, you can have more spot instances handling your production workloads. And in night times, what we do is we recycle through nodes. So in every, like when your system is running and when your system is using spot instances, there always exists a cheaper configuration of spot instances, but your system is not configured to change it, because spot interruptions are, in general, we try to avoid it as engineers, right? But at night times, what my team does is we recycle through all the nodes, so that we achieve, for the night time, we achieve the most cheapest configuration of running our production workloads. So that's something that I see many teams missing. This can also help you. And these are the outcomes that we have been able to achieve. So this is like all the drops in the graph. These are the nighttime downscaling and recycling of the nodes. Right pricing basically means you categorize all your workloads. So if it's an interruptible workload, you can put it on spot and save cost. If it is a critical, you'll have to run on demand. And if it's a predictable, like let's say a particular baseline is always there. Let's say if your workload at a baseline level requires at least 1,000 CPUs, right? So you can make a commitment to your cloud provider and get a discount on it. So this is something that will help you run the same thing and don't need to make any changes. You can just commit and then you can get discounts. So see what makes sense based on the nature of your work. After you have identified the data, you have worked on the hidden waste, you have also optimized it. The next step is to maintain this baseline. Like whatever savings you have achieved, you now want to continue with that. You don't want that, okay, I put effort this month on saving costs, but next month something else went wrong and now we are back to where we started, right? So this is very helpful, that you should automate some ways by which you can impose some cost discipline on your team and on your infrastructure. Few ideas around it. These are few that we have in our team. So we have cost anomaly alerts. We have budget alerts, like each team has a budget, and if they exceed that, then they'll get an alert so that they're more careful or they can plan accordingly. And we have scheduled reporting. We send summaries of our cloud. That summary has a very detailed analysis that, okay, the cost of S3 has increased by 5%, 10%, and followed by which part of S3, like is it due to data retention, data storage, or is it due to the fact that we are serving more requests? So that type of summary really helps instill a cost discipline in the team. These are a few examples that you can use, few ideas. Now the next part is of actually building something that removes your constant human intervention, because cost is something which requires a lot of context and a lot of diving deep. Like if there's, let's say, if there's a increase in your data transfer cost, you'll have to go very deep to find out what is going wrong, which instance is actually causing it, how much is the loss, is the cost increasing. So LLMs could really help with that, and this is something that my team has been experimenting with. We can use LLMs to analyze patterns and recommend optimizations. So the goal that you can use with LLM based approaches is that for everyone to have enough context, enough tools that they can query and see their cloud costs themselves. They don't need platform engineers intervention, and AI agents can really help with that. Just to give you an example, I was one of my colleague actually built something around it. They built a NA10 where like they self-hosted a NA10, and we feed the NA10 data about our cloud cost, and then we had a AI agent query that. So anyone who does not have context of the AWS cloud, even they can ask question that, okay, why is the S3 bucket this and this, like whatever the name is, has increased in cost from January to March. And LLM will be able to, understand that understand that question, contextualize it, and then look at the data to give an answer. So we have been experimenting with such ideas, and these are few more that that can help. One can be a cleanup agent, which can just delete any idle EBS volumes that it can find, or any S3 bucket that might have been provisioned for a POC but it's no longer being used. Those type of things. So yeah, this is the workflow, and so yeah, understand, discover, optimize, automate, and then put a AI so that you can automate most of it. You don't require some monthly auditing or a lot of human intervention. So this is how you can think about cloud costs, how to keep cloud costs low and your finance team happy. That's all. Thank you.